Today, we're going to be talking about ice ages, how they work, and how we can actually stop them through global warming. Now, ice ages are less extreme than you might think, and they happen when the Earth has very cool summers in the northern hemisphere that fail to melt the ice sheets that grow every winter. The reflective white surface of the ice also increases the cooling, and the positive feedback loop makes most of the Earth very cold, while the equator actually stays pretty warm. Scientists can estimate recent temperature cycles using ice cores, and they find that there is a cold period that we consider an ice age about every 100,000 years. This happens to coincide with the Milankovitch cycles of Earth's orbit and rotation. So every 100,000 years, we'll have a cycle in the eccentricity of the Earth, which is a measure of how circular the Earth's orbit is, and this will be caused by interactions with other planets. Now, when the eccentricity is high, the orbit will be less circular, and depending on the precession, either the winter or the summer will be more extreme in a given hemisphere. We also have the obliquity, which is the tilt of the Earth at every 40,000 years, and a higher tilt will also make summers more extreme. And when all of these line up, we get unusually cold summers in the northern hemisphere, and the ice sheet expands like crazy. The last glacial maximum even extended into the central United States. And here is our current value for eccentricity, and you can see that we're sort of in an in-between period of the most intense summers and the most cool summers. And our precession and obliquity, the two other factors in the Milankovitch cycles, are actually favoring a northern hemisphere with slightly cooler summers. And so this can cause more minor changes in climate, like the creation of the Sahara Desert, for example, which didn't exist in its current state at around 5,000 years ago. And I've actually made another video about this on my channel that I'll leave down in the description. Now, going back to the ice cores, we could get these very accurate measurements for CO2 for the past 800,000 years. And what we see is that very recently we have very elevated levels of CO2, mostly related to the burning of fossil fuels. But as we look much further back in time, through testing of rock isotopes and fossils, every estimate for CO2 is much higher. No ice cores go back this far, and none even go back further than 1,000,000 years. So the methods get less precise, and sometimes disagree. But most of them estimate CO2 at well over 1,000 parts per million in the time of the dinosaurs. But as you can see on this chart with the cyan boxes, periods with ice ages and polar ice caps are actually somewhat rare. So if we just increase CO2 to around 500 or 600 parts per million, we can expect ice ages to end. And if we just keep our current level of fossil fuel use, the period that ended 10,000 years ago could be the last ice age in the history of Earth. So why has our CO2 dropped to such a relatively low level? Well, the main reason is during the time of the dinosaurs, that very abundant level of CO2 got trapped underground, and it's now in the form of fossil fuels. So as you might expect, if we burn literally all of the fossil fuels underground, we can return to these same levels of CO2 or even exceed them. Now, we will probably only use the fraction of fossil fuels that is cheap to extract from the Earth, but if we somehow just burn all of them, then most estimates predict we'll see CO2 concentrations of around 1,000 to 2,000 parts per million, compared to around 400 parts per million today. So this is where you see these estimates of these high emissions scenarios, or the low emission scenarios, that scientists will predict. It's mostly just based off how much fossil fuels are burned. So if CO2 levels get this high, we will definitely be safe from any potential ice ages, but we will have some major changes that these climate activists are frequently talking about. So what you see here is a model of the Cretaceous period, estimated at 1,000 parts per million CO2 and no ice caps. The first thing you can notice is that the change in temperature is greater in higher latitudes, and the equatorial regions change somewhat less. So if you've heard about the runaway greenhouse effect, this is distinct from the normal greenhouse effect, and this is not possible on Earth because it requires temperatures hot enough to boil water, which then becomes the primary greenhouse gas. Venus orbits at 72% of the distance of Earth from the Sun, so due to the inverse square law, it actually receives double the solar radiance that we get on Earth. In the history of Earth, despite periods with very high CO2, it has never gotten this hot, which is why we have abundant water and Venus has none. So it is not possible to literally destroy the Earth with greenhouse gases, but it will cause some major changes that we'll talk about next. First of all, if the ice caps fully melt, this will raise sea levels up to around 200 to 300 feet and then stop rising there. And as you can see, this will cover many states and countries in water, but this process would probably take thousands of years. But you can also see that we will get some new land that appears as the ice sheets of Greenland and Canada and Antarctica disappear. And when you add it all up, we will lose about as much land as the lower 48 states of the US. But maybe the warmer temperatures in Canada and Russia would make up for it in terms of how much farmland we would have available. Another interesting impact of an increased temperature is the ability of the air to hold on to more water. And this will also change the land-ocean temperature differential, changing the overall climate. So this is where the idea of increased natural disasters comes from, since there would simply be more rain, clouds, and necessarily more storms. Also, there are some other complicated changes to differences in temperature with the oceans and the land that can cause some weather changes. So each of these sort of terraforming paths has different pros and cons. The sustainability path would mean more ice ages at some point down the road, and the middle road would be no ice ages and also no huge changes to sea levels. And finally, you can actually make an argument that the high emission road is the best in the long term. But of course, this would have pretty drastic changes that most people perceive as bad. So I think this ability to sort of terraform Earth is really interesting, and it really seems like we'll not be having another ice age really anytime soon, and probably really ever, considering Earth will probably only be around for around 1 billion more years as we know it today. So I hope you learned something in today's video, and if you like this video, left some similar ones down in the description for you to check out, and then make sure to like and subscribe to the channel. And with that being said, have a great day.